one thing that I really love about behavior analysis is the replication aspect. So one of the powerful things about using a single subject design as opposed to like a group design is with the single subject design, you can actually show a functional relationship, and that's really through the replications of our experiment using non-objective data to determine what's going on. And we can determine a functional relationship between the independent variable and the dependent variable. And that's what a lot of people call a cause. That's a causal relation. It's more accurately determined or defined or described as a functional relation. So that's what I'm going to call them. I'm going to call them functional relationships. And through that, we can get functional relationships. Because what happens with a single subject design? First thing we do, we wait for steady state responding. We don't say, what's going on? Take this test, do this, engage in this behavior. We don't just give someone a task, get one data point, done. No, what do? You wait for steady state responding. And then you try to get that that description of what's going on. You try to predict what would be next, and then you do the verification through it. We got all of those tips and tricks and techniques, and that's what makes our science so powerful. I'm not going to go into great detail because that's not what this video is about. This video is about the this is about the attitudes of science, but it's through replication that makes our personal the science that not I say ours. You can do anything. You don't have to be a behavior analyst to watch this video. But as a behavior analyst, as me catering to behavior analysts, we wait for that steady state responding. We got a data point, replicated. What do? We do something else. Oh, we get the data point. It's going down. We got a trend. Replicated. We get this. Then we go back to baseline. And then we go back to intervention. Replicated. That replicated. Now this whole condition is replicated, and within that condition, replicated. And now we have this over here. Oh, we replicated this whole condition's replicated, and then within the replication, we got replication. That was a little obnoxious, I know. For all you charting nerds out there, I wonder what my rate or frequency of replications per minute or people want to criticize single subject designs. Part of it is because we use some weak visual displays. We're not using standard charting conventions that almost every other science would use. We make our own Excel graphs, and they're not that powerful. So statisticians and things of that sort, people who cannot come up with functional relations, but can only come up with correlations, they think that their science is better, that the correlations is better than the possible functional relationship, because they can come up with a number and say it goes from like 32 to 84. And they can come up with the significance of that number, and they have a bunch of numbers, and they have measurement. They have empirical information about what's going on. But they never replicated it. They usually have this data point. We ask everyone this question, and we ask everyone this question once, and we're done. It's not been replicated. And a lot of science, the statistical science, they have a hard time replicating these designs. But people want to say they're stronger than single subject designs. We have more information. We have numbers. In one single subject design, with one participant, do you see how many times I had to say replication over and over and over again? We really replicate it to make sure what's going on. Oh, and we're not even done yet. You know what we do? This is participant 1. Then we have participant 2. We have participant 3. And what we find out is all those replications, within condition replications, across condition replications, we have within participant replications of conditions, and then across participant replication of conditions, and then all the within and across conditions within there. It's replication after replication after replication. So if you do it right, if you came up with a solid, valid experimentation, you have good data, with a good visual display, something that everyone says, you know what, you really showed some good information there. We can all believe it. What you measured is valid. It's reliable. It's believable. It's all of those things. We got good data. We can come up with some really good determinations and come up with some really good science. Determinations of science, determinations of the world, And that's what I'm calling science. That's what it is. Science is coming up with a system to determine what's going on in the world. So anyone that complains that we don't have replication, they're like, oh, there's only 4 participants in your study. We had 75. Well, really, you want to do statistics? I think you need like 250 per condition to really start getting like a good amount. So that's like, what, 500 people total? That's to get these 2 data points. You need 500 people to get this data point and that data point. We have 3 individuals total, and all of those, every time I obnoxiously said replication, that's all been replicated. So I feel like I've replicated the replication talk.